Welcome and thank you for joining me in this lesson. Here we're going to talk about the equations of lines in 3D space. Recall that in the previous lesson we talked about the equation of a line in 2D space. And the equation in vector form is xy, where xy are the coordinates of any point on the line, equals x0, y0, that would be a starting point on the line, plus some multiplier t, a scalar t, that multiplies the direction vector whose coordinates are indicated by letters A and B. Now we are shifting the same concept, or we're trying to write the vector equation of a line that is in 3D. And the equation will be very similar to 2D, but because we have a third dimension, so we're going to add the z coordinate. So x, y, z would be any point on the line. And the starting point, obviously, will have a third coordinate, so we're going to add the z0 here. So x0, y0, z0 would be a starting point on the line, which would follow the direction vector, which again will have three coordinates. So we're going to add a third coordinate, and we're going to call it z. Z equals c. So the vector equation of a line, in general, is r equals r0 plus t times the direction vector. And the parametric equations, so remember this is the vector equation, so parametric equations will give the equations for each parameter or for each coordinate on the line would be x equals x0 plus ta, so x equals x0 plus ta, y equals y0 plus tb, and z equals z0 plus tc. Now, r0 is a vector from the origin to the point x0, y0, z0. Remember that we call this the vector equation of a line, right? So here is the starting vector, and the line is following the direction of some direction vector here, okay? And it has a starting point at the head of the starting vector. Now, A, B, and C will be the direction vector. So the direction vector can be this one, or it can be this one, or it can be even longer than this, right? So we're going to take a look at the first example. So how do we find the direction vector of a line in 3D? So we're given 2 points, A and B. We have to find a possible direction vector. Now remember that, or I want to bring your attention to the word possible. So this tells me right away that there may be more than one direction vector. And as a matter of fact, there is an infinity number of direction vectors that we can create. And let's get started with writing the information given. -1, 3, and 5. For A and B is -3, 3, and -4. So we're going to say that if a line passes through 2 points A and B, then the line must follow the direction of AB. So it can follow the direction of AB this way or the direction of AB this way, right? It doesn't really matter. So we're going to say that if we knew the coordinates of vector AB, then we can figure out any vector that is parallel or it goes in the same direction as AB. So that would be -3 minus -1, 3 minus 3, and then -4 minus 5. Recall that to find the coordinates of AB from coordinates of B, we subtract the respective coordinates of A. So -3 minus -1, 3 minus 3, -4 minus 5. And then we obtain -3 minus -1, -2, and then we have 0, and then we have -9. So the line will pass through AB. We might as well call this the direction vector, -2, 0, and -9. But any multiple of vector AB can be considered as the direction vector of it. So other direction vectors can be M equals, I would divide by 2 every coordinate, so I will take half of this direction vector, so that's -1, and then 0, and -4.5. I can divide by 3, that's another one, so that would be -2/3, and then 0, and then -3. I can divide by or multiply for that matter by -5, and then you get +10, 0, and then 45. So just to get you an idea of how the direction vectors work, right? So it's not a fixed value. Now, in the next example, we are going to represent the equation of a line in R3 in vector and parametric form. So that's what we'll practice. So we have 2 points, P and Q. That's where the line is going to pass through. So first of all, what I like to do is write the equation that I'm trying to create. So I'm trying to create an equation in the form xyz equals x0, y0, z0 plus some multiplier t, and then we go a, b, c. And as a starting point here, so x0, y0, z0, or as a starting vector to be more precise, we can use the coordinates of any of the points as the head of the vector. So I will use in this case the coordinates of point P, and I would say that the starting vector will have the head at -2, +3, +5. And then plus t, now we have to figure out the direction vector. We just practiced how to find the direction vector. We're going to say that the direction vector m can be PQ itself or any multiple of PQ. So that means that we have PQ -2 minus -2. That will give 0. Next, y coordinate 4 minus 3, that will give 1. And for z coordinate, -1 minus 5 is -5. So this can be a possible direction vector. Again, any other multiple of it may work, but I'm going to leave it at 0, 1, and -5 for now. And we'll say that the vector equation of a line that passes through the indicated points P and Q would be xyz equals -2, 3, 5 plus t, 0, 1, and -5. Now, another possibility is to input the coordinates of Q for x0, y0, and z0. It would still represent the same line because remember that lines are never ending, which means that there is no direction in which you want to read them. So we can read the line going this way or going this way. It doesn't really matter, right? So, which means that if the point P is in here and we follow the direction of a direction vector, that can be the line. But we can also start from point Q and follow the direction vector this way, or any other direction vector this way, because the line never ends and you can extend it at both ends.